Hello everyone, this video is about momentum past paper questions. Number 1, read the question. So P is moving to the right 2 meters per second, the mass is m, Q is stationary, the mass is 0.2. Before the collision, after the collision, P is moving to the left because it is going in the opposite direction, minus 0.5 to the left, and going to the right, so positive 1 meters per second. And the momentum must be the same before and after, and you can find the m. Now this one, read the question. So the initial velocity of A is 30 upwards, G is always 10 downwards, the distance between them 15, and B is released from rest. The distance SB plus SA is 15 because the distance between them 15. So we want to make the SB and SA both positive because we say that SB plus SA equals 15. So this must be something positive, something positive. So that's why for the distance calculation, displacement, we use going downwards is positive. So the 10 is positive, and we can simplify this into this, and for the A we say that going up is positive, so that the displacement upwards is positive, and the acceleration downwards is therefore negative, and you can find the time when they meet. After you have the time when they meet, you can find the velocity just before they collide, the velocity of B, velocity of A. And now using momentum, this is the momentum before the collision. So going upwards we say it's positive, going downwards negative, and since they coalesce, they stick together, the total mass times the velocity after the collision. So after the collision, because the total momentum is positive upwards, of course they're going to go upwards. So this is the velocity after the collision. Right after the collision, the velocity is this, using the momentum conservation. So we have two possibilities here because there are two possibilities. The mass of A and the mass of B can be twice one another. So if the mass of A is twice the mass of B, we get this. If the mass of B is twice the mass of A, we get this. So we have two possible velocities after the collision. The distance traveled going down back to the ground is the same as this as A. So from here you can just replace the time with 0.5. We get the distance when they collide. So this object will go up and then reaching maximum height, and then go back down, traveling this distance here. This is actually in meters only, and therefore the time to reach the ground can be, from the first possibility, this is S equals ut plus 1/2 at squared, we get its time, and if the initial velocity is 5, we get this time. Question is the difference between the two possible times, so we subtract and we get the final answer. And in this question we have, just read the question. So B to the left 2 meters per second, A to the left 2 meters per second. So we don't really care about the inclined plane because we just know the initial velocity before the collision, 2 and 3, it's given, and after the collision the A is slowing down a little. We can find the V using momentum conservation. Now the object B is still going down with this acceleration because of sigma x Fx equals ma, and the only force in this direction is W sine, so the acceleration is 5, and we can use v squared equals u squared plus 2as, or v equals u plus at, to find the v, which is 5. This is only meters per second. There's no square actually here. So after hitting the barrier, because 90% is reduced, only 10% remaining, so 0.5 meter per second is the velocity after hitting the barrier. And now after hitting the barrier, B is going up the slope with this velocity, and A is going down the slope with this velocity. This is after A is colliding with the B. So they meet again, they collide again after 0.44 seconds. This is after A is colliding with B for the first time, and this is the velocity after it goes back up. And we know that we need 0.04 seconds from the B rebounding from the barrier going upwards until they meet again, 0.04, and A going down until it collides with B again, 0.44 seconds, and the acceleration is the same for both B and A, and therefore we can find the velocity when they meet. Here the velocity when they meet would be v equals u plus at. We get 0.3, 4.7. This is exactly when they meet. This is going up the slope, 0.3. So let's say going up the slope is negative, going down the slope is positive. We can find the velocity of the combined bodies, because they coalesce, they stick together. This is the combined velocity. That's it. I'll see you again next time.